Okay, good morning. In the previous lecture, we had started discussion on the all outdoor air applications. Okay, so we discussed that there are certain things. For example, if you go to operation theaters, ICUs, okay, and even in certain industrial processes, here we will be having requirements so that bacteria and microorganisms cannot grow. Okay, so in such areas, such applications, what is done? Whatever is there within the room, that entire air is sent outside, and we try to fetch the entire supply of fresh air from the ambient conditions. Under this circumstance, what typically happens, because the ambient air is coming at very high temperature and we are not doing any amount of recirculation, which is typically done at the room conditions, TI conditions, which are less in comparison to the T0 conditions for summer air conditioning applications. That's why the load on the cooling coil increases significantly. However, if we try to see the process on the psychometric chart, so process on the psychometric chart is something like this, that this is my outdoor state, this is my indoor state. Okay, now as I told you that we are not doing any mixing of the outdoor and the indoor air, because indoor air is completely sent outside and outdoor air is completely passed over the cooling coil. Therefore, the outdoor air will be directly passed over the cooling coil and there will not be any contact of outlet air and the inlet air. That's why we will not be able to join this line in between O state and I state. Is this one clear? So from this, say my apparatus ADP is this one. Say this is my ADP. Okay. If this is my ADP, then this line from 0 to ADP is something which is representing the actual load on the cooling coil. Is this one clear? So this is the line which is representing the total load of outdoor air which is acting on the cooling coil. Is this one clear? Now we know that we will be having certain amount of bypass factor. So because of the bypass factor, my state which is coming at the exit of the cooling coil will not be exactly equal to TADP, but it will be somewhere at some point number 2. Is this point clear? All are clear with this point or not? Now, this air at state 2 must enter the room. So when it will be entering the room, of course it will be in some cold state condition, and from one end of the to the other end of the room, whenever it will be moving, it will try to cool down the different heat sources within the room, and it will, in other end, its temperature must become equal to Ti. Is this point clear? Now we will be, from this particular point, we will be talking about two different quantities of air. One quantity of air is something which is called as outdoor air. It means from point O, how much amount of air I have taken, that is Q. And second quantity of air I will be calling the dehumidified air. What is dehumidified air? The amount of air which we are supplying to the room. Basically, it is nothing but QS. The amount of air which we are supplying to the room. So QS is entering the room, say at state 2, and then it is reaching to state I. Is this one clear? Now we have three possibilities. First possibility is QV0 is equal to QS. When QV0 is equal to QS, we need not to worry, because ultimately what is happening, whatever amount of outdoor air is being cooled over the cooling coil, if that particular quantity is equal to whatever supply flow rate of air is needed within the room, if supplied at state 2, then we do not have any issue over here, because both my cooling coil load as well as the both my cooling coil load as well as what is other load? Room sensible heat load and room latent heat load, these are being satisfied. Is this point clear? So it means supply of QV0 and QVS are same and QS is adjusted in such a way so that it enters the room at state 2, it will be completely satisfied. Is this point clear? Second scenario could be that QS is less in comparison to QV0. Or first let me take, okay, QS is less in comparison to QV0. What it means? It means that the amount of air which I am cooling, that is more in comparison to the amount of dehumidified air which is required to meet the room sensible and the room total heat condition. In this case, we can do two things. First thing is, if the difference between QS and QV0 is small, so if QS minus QV0 is small, then what I can do? I can simply change the bypass factor. I can slightly increase the bypass factor of the cooling coil. So in this scenario, I can increase bypass factor. If I will be increasing bypass factor, what will be happening? If I increase bypass factor, what will happen? Please tell me. If I increase bypass factor, the state 2 will go somewhere here to new state 2 dash. Temperature will be increasing. So if temperature is increasing, automatically it will be adjusting to the more amount of flow which we are actually supplying. Is this point clear? Then second situation could be that QS minus QV0 is actually large. If QS minus QV0 is large, then what will happen in this scenario? Please tell me. If this is large, then just adjustment of bypass factor will not be working. In this scenario, what we need to do, because my outdoor air, whatever I am taking, that is, its amount is more and its temperature is also less, T2. So in this scenario, I need to do reheat. Is this point clear? So what I will be doing, I will be slightly heating this from 2 to S and my process 2 to S will be becoming the reheat process. Okay, because whatever amount I have taken from outside, that is more and its temperature is also less. So ultimately I need to adjust the temperature to a value where it can meet the room total heat load. Okay, if it is not meeting the room total heat load, if it is extra than the room total heat load, then it will be further leading to the cooling of the room. It will not maintain the room at the state I. Is this point clear? And the third scenario could be that QS is greater than QV0. What it means? It means supply air state is, the dehumidified air quantity which is required, that is more in comparison to whatever the amount of air which we are taking. In this case, what we need to do, we need to simply increase the speed of the fan and we need to increase the value of QV0 in order to maintain the dehumidified air quantity. Otherwise, overheating of the room will start. Is this one clear? Now, based on this concept, so here you can see from the psychometric chart that there is no joint in between the outdoor condition and the indoor condition because we are not allowing mixing of the air, but instead what we are doing, we are allowing the entire air QV0 to take from outside and that QV0 we are passing over the cooling coil and ultimately we are adjusting the flow rate of QV0 in such a way so that it meets the corresponding room total heat load conditions. Is this point clear? So this type of system is typically preferred in hospitals and intricate processes where the growth of bacteria and microorganisms is not desirable even to the smallest extent. Okay. Now let's again I will be just reading the statement. Is this problem number 6 or 7? Probably it should be 6. So the outdoor dry bulb and wet bulb temperature are 38 degrees Celsius and 28 degree Celsius. So T naught means T dBT naught. Okay, T dBT naught is 38 degrees Celsius and T WBT naught is 28 degrees Celsius. Okay. The indoor design conditions of an operation theatre and anesthesia room are 24 degrees Celsius and 50% relative humidity. So indoor is 24 degrees Celsius and RH is 50%. Okay. Now what is given in the question that RSH and RLH are, RSH is 15 kilowatt and RLH is 3 kilowatt. And the fresh air requirement is, so QV naught is how much? 50 cml. That is given in the question. We need to find the supply air state dehumidified air quantity. So what are the parameters we need to calculate? We need to calculate supply air state and dehumidified air quantity. So what do you mean by dehumidified air quantity? QS. Fine. And it is given in the question that X we can consider equal to 0.05. Okay. Now what will be the first step? Please tell me. W naught and Wi. So how much is Wi? 0.009339. Correct. What is W naught? How many of you have done this problem? W naught 0.0199. Okay, what should be the next step? What should be the next step? Can I calculate, sorry, RSH? How much is RSHF? 15 by 15 plus 3, which is equal to 0.83. Okay. Then what should be the further next step? ADP. Okay. ADP, generally, can I calculate ADP from RSHF? When there is involvement of ventilation, then for estimation of ADP, we need to go for Grant sensible, either Grant sensible heat factor or ESHF. Okay, Grant sensible heat factor works very well when there is zero bypass factor. Okay, but if there is finite amount of bypass factor, then we need to go for ESHF. Okay, for calculating ESHF, what we need to do? OASH. How much will be OASH? 0.0204 QV naught T naught minus Ti. Okay, how much is this value? What next we need to do? OALH, its value should be 50 into QV naught W naught minus Wi. How much is the value? 26.53. Okay. Then after this, what I need to do? ESH, it will be RSH plus X times, how much is it? 15.71. ELH, similarly RLH plus x times OA LH. How much is it? 4.33. Then I'll be having ESHF. How much is ESHF? ESH upon ESH plus ELH. Clear? What is the value? 0.7841. Okay. After this, what I can do? If I know ESHF, then I can calculate where ESHF line will be crossing my saturated curve. Corresponding to that, I will be able to calculate my TADP. Okay, so how I can calculate? Please tell me. What is the process? That is iterative process. Can we get rid of iteration? One method is we calculate slope, assume values, corresponding to that keep on verifying, but it's an iterative process. Can we have some better option?
Statement I says
O we know, I we know. Okay, I know SHF, I know ESHF,
yes.
I know alignment circle. From ESHF to alignment circle, I will be drawing a line. Then parallel to that, I can draw a line from I. This is my which line? ESHF line. ESHF line will cross the saturated curve at ADP. So what is my TADP?
8.51.
TADP, please. Any other value? Any other value for TADP? Can someone tell me other value for TADP? Please tell me. How much is TADP? Sorry?
7.5.
No. 10.2?
8.90 means
That's why. Please check again. Are you getting 10.2?
10 से कम ही है.
Ten point two. Please locate the state correctly.
State to already
Please. 0.784. There is linear scale. Sorry? Okay, you are able to go to up to 0.78. Then 4 you can in between 7.8 and 7.9 choose a point. Okay, it is more than 10, na? So it is 10.2 degrees Celsius. Okay. Now if you know ADP, you know bypass factor. Can you calculate state 2?
Yes.
How you can calculate state 2? Please tell me. X equal to
T2 minus
hmm,
10.25
I am drawing ESHF line. Okay, on ESHF line, somewhere here I will be having state 2. So this is my X. Okay, so from here, if X is equal to, it can come as T2 minus TADP upon TI minus TADP. So how much will be T2?
10.91.
10.91.
10.89.
Give me single value. 10.91. Okay, so let me write 10.91 degrees Celsius. Now, if air is entering at T2 state, okay, which is 10.91 degrees Celsius, and it is entering in the room and going to state I, can I write that ESH, effective sensible heat, will be equal to 0.0204 QS, where QS represents the dehumidified air quantity, that must be equal to Ti minus T2. From here, can you calculate how much is QS? How much is QS?
Fifty-eight point eight three.
58.83 cmm. Are you able to relate to any of the previous case which conceptually I discussed? Are you able to relate or not? Dehumidifier air quantity is 58.83. How much air you are taking from the ambient? 50. You are taking 50 and you are cooling that to supply state T2. Okay, but actual corresponding to this T2, the actual amount of dehumidified air which is required to meet the effective room sensible heat, it means effective room total heat, that is 58.83. It means my amount of outdoor air taken is less in comparison to dehumidified air quantity. In this scenario, if I just keep on passing only the 50 amount, then overheating will start, and soon I will be finding that my state I will not be maintained, but temperature will keep on increasing. But that is not the requirement. Requirement is I should be able to maintain the constant indoor conditions. Okay, so what I will be doing now, please tell me. The next point is, in order to maintain the room condition, what I told you in that conceptual understanding, that if the amount of volumetric flow rate which we are taking from the ambient, that is less, then we will be switching on the fan speed, or we will be fully opening the dampers. If I have partially opened damper for certain purpose, then by adjusting the damper I will be increasing the QV naught in order to meet its value equal to that of what? QS. Okay, so now let us assume that I have increased QV naught and I made it equal to QS, dehumidified air quantity, which is 58.83 cm. Is this point clear? Now, please see one thing, our question is not yet done. Why? Because I increased the flow rate, but bypass factor of cooling coil is same. Okay, so if With flow rate of 50, cooling coil was able to maintain supply state 2. With flow rate of 58, supply state will be different. And if here amount of flow rate is increased, it means the temperature will be more higher. Is this point clear? What I have done, I have same bypass factor, but I increased the quantity of air which is passing over the cooling coil. When I increased the quantity of air, then ultimately at the exit of cooling coil, whatever state I will be getting, its temperature should be greater than temperature of state 2. All of you agree to this point? So it means that by just increasing the flow rate, it will not serve our purpose. We also need to test that corresponding to this new condition, what will be my new ADP, and because when I have increased the air quantity, if bypass factor is not changed, then ultimately for increased air quantity, I also need to decrease the temperature of the cooling coil. Is this one clear? Because why? This 58 will only satisfy if I am able to maintain the same state. To maintain same state, if I increase the quantity, I must decrease the ADP of the cooling coil. Is this point clear or not? This is interrelated concept. Okay, so that's why you should be able to understand this. So it means by just increasing the flow rate, it will not serve our purpose, but we also need to test that corresponding to this increased flow rate, what should be my temperature of the cooling coil. Okay, what should be my new ADP. So how I can do this? Now simply I need to repeat the process. How? I will first calculate OASH corresponding to new value of QV naught. So 0.0204 new QV naught, let me make it as Q dash V naught. Q dash V naught into T naught minus Ti. How much is it? 16.78, yes. OALH, I am not writing the formula now, directly the value. What is the value OALH? Please tell me the value for OALH. 31.17. Yeah. Now I will be calculating new effective sensible heat load. How much is it? .84. ELH 4.56. ESHF 0.776. Okay, 0.776. Tell me new ADP. How much is new ADP?
Or 4.
10 point, it should be more or less? It should be less, because flow rate you are increasing, it should be less. Okay, so something, for example, if on the chart you are not able to exactly locate, but you will get some hint from the question itself. It will be, how much is the value? (10.1°C). 10.2 was previous value, current value is 10.1. Okay, so if you calculate very precisely, you will be finding that this new line which is moving from I, it is very close to Now I have got a new line. Please see over here. Green line is corresponding to previous ESHF. New line is corresponding to a black line, new ESHF. And it is crossing at temperature of so T dash ADP is how much? 10.1 degrees Celsius. Can you calculate T2 dash now? X equal to
10.7. T2 dash 10.7.
T2 dash minus T dash ADP upon Ti minus T dash ADP. From here T2 dash is how much? 10.79 degrees Celsius. Okay. So it means corresponding to new flow rate of the ambient air and new ADP, you have got the new supply state. Now you need to test whether this new supply state is again able to meet the room total load. It means its flow rate is again coming same as that of the previous dehumidified air quantity or not. Okay. So again I will check the dehumidified air quantity. So new ESH must be equal to 0.0204 into QS dash, new dehumidified air quantity. Okay. And how much? Ti minus T2 dash. How much is QS dash? 58.79 cmm. Now you can see QS dash is nearly equal to QS, almost same. It means that with current amount of air which you are taking from ambient, that is, it is equal to QS and it is equal to Q dash V naught. Okay, it is equal to Q dash, new amount of supply air state, which we are new amount of outdoor air which we are taking from the ambient. It is exactly matching. What it means? It means that my purpose is served. Okay. So D.
Difference.
It's okay.
Changing by 1%.
It's okay. You will not be able to meet the exact value. It's an engineering calculation. It's not scientific research calculation. Okay. Is this one clear? One more part is left. Probably it is also asked to calculate that. Okay, we have done, I think, everything we have done. Okay. So how many of you have done this problem before? Okay, so you have used book for doing this problem. Now is there any, sorry, ADP के लिए. Okay. No, that's okay. But my point is, do you have any difference of understanding the question, whatever you have done previously and now, or you got this idea before also? Okay, now let's do the next problem. The outdoor. This problem probably I will not be able to do it fully, so I can explain you the steps and then you can do it by your own. Okay. The outdoor dry valve temperature is 32 degrees Celsius and relative humidity is 50%. T naught is 32 degrees Celsius, RH is 50%. The indoor design conditions are again same, 24 degrees Celsius and RH is 50%. The RSH and RLH are 15 kilowatt and 3 kilowatt respectively. So RSH is 15, RLH is 3 kilowatt. Okay. The cooling coil cools only the outdoor air, which is then mixed with recirculated air as shown in the figure. Okay. So, one figure is given in the question, and as per that figure, this is the room. Of course, room will be having TI conditions. Okay. And then from the room, some air is taken out, however, some amount is recirculated. Okay. And then I have a cooling coil, and this cooling coil is installed just before the recirculated air, and this is my mixing chamber. So what is done? First, outdoor air is taken. Outdoor air is actually cooled in the cooling coil, and then it is allowed to mix in a adiabatic mixing chamber. After the mixing chamber, with the help of a fan, air is circulated to the room. So this is the figure. It means that first we are just cooling the outdoor air only. Again, we are not mixing O and I. We are cooling the outdoor air, bringing that to some state 2, then state 2 and intermediate state I are mixed together to bring some supply status. Is this point clear? So the diagram on pH diagram, it will be represented with different arrangement. Bypass factor is 0.1. So X is given in the question as 0.1. We need to find supply. Okay, the supply air volume flow is 180. QS is equal to 180 cml. What is the meaning of QS? It means flow rate over here at this point. After mixing, flow rate is 180 cml. Okay, and we need to find the supply air state, its mass flow rate, state at the exit of cooling coil, and the total cooling load. So what are the things we need to calculate? Supply air state, its mass flow rate, state at exit of cooling coil. What it means? It means that the state of outdoor air which is cooled at the exit of the cooling coil, and the last part is total cooling load. What is the total cooling load which is acting on the cooling coil? So these are the things we need to calculate. Can you solve this question? We have done so many now. What should be the process? If you see on psychometric chart, how I can represent this? Please tell me. Let me also specify some state points. Okay. Let me call this state as S, which is after mixing. Recirculated air over here will be state I. This state over here will be O. Let me call this particular state as state 2, which is at the exit of the cooling coil is state 2. Okay. And you also need to know that corresponding to I will be having over here, this will be my QVR, recirculated air. This will be from here QV naught. And here it has to be equal to QV naught, because ultimately the supply air state should remain the same. Is this point clear or not? Anyone is having any doubt about this? Please tell me. Okay, so yeah, now what will be happening? Please tell me. I will be having outdoor state, I will be having indoor state. All are clear with this point or not? Then outdoor air is cooled and it is reaching some point. Which point? 2. When it is cooled over the cooling coil, having this as ADP, it is reaching which state? 2. After that, what you have done? You have allowed mixing of 2 and I. So 2 and I has mixed, and when 2 and I has mixed, these resulted in which state? S. And then state S is entering into the room. So this will be the psychometric chart for this figure. Because I explained you psychometric chart, now you can easily calculate this. It should not be very tough for you now. Am I correct? Will it be tough or not? Because everything I have shown to you. Okay, what is to be done first? WIW naught. Tell me WIW naught. What are the values?
0.0093.
W naught is
WI.
WI is 0.0093.
009.
Yeah, WI will be same. And what about W naught? W naught is how much?
0.015.
0.0.
0.015.
0. Let me check. Yeah, 0.015. Correct. W naught we have calculated. What next? Partly psychometric chart I have explained to you. Partly. Some additional thing is to be done over here. Can you tell me how we can proceed further? I know RSH, I know RLH. Okay. If I know RSH, I know RLH, I also know QS. Can I calculate TS and WS? Very simple. S state can you calculate or not? QS is given in the question. How much is? So basically S to I is which load? Only RSH and RLH. This is a room sensible heat factor line. So RSH will be 0.0204 QS into TI minus TS. From here can I calculate TS? How much is it? 19.91 degrees Celsius. From RLH, which is 50 times QS into WI minus WS. If you calculate WS from here, how much is it? Please tell me. How much is that? 0.009, correct. Okay. Then, if I know TS and WS, can I calculate the mass flow rate of supply air state? It is asked in the question, how much is mass flow rate of supply air state? Can I calculate? Please tell me. Volumetric flow rate of supply air state is given. Okay. I need to calculate specific volume. How I can calculate specific volume of supply air state? Already given you the equation of state. RA into T 1 plus 1.6078 WS, here it will be TS upon T. Given to you or not? How much is VAS? if this is VAS, then what is mass flow rate? 3.563 kGa per second. Okay. So up to this point it is okay. How to go further? Please tell me. Now there is difficulty. Because do I have any way out to calculate T2 and TADP? Any possibility you are seeing that how I can calculate? I don't know how much air is recirculated, how much air is taken from outside. It means I don't know QV naught. I cannot calculate OASX. I cannot calculate effective load. What is the possibility? Okay, figure out the possibility. We will discuss this in the next class.